everyone. Today our lecture is all about transient characteristics. Okay, so I will show you how to tackle any transient problems in a very short way. Okay, so for this you have to know these three characteristics. Okay, these three time characteristics. Okay, so these three time characteristics you have to know, and according to this time condition, you have to replace capacitor, inductor and resistor in the corresponding circuit. Okay, so we have to know the significance of this time. Okay, the t is equals to 0 minus, t is equals to 0 plus, and t greater than 0. What is the significance of in this circuit? Okay, so suppose this circuit is given. Okay, for better understanding, I have assumed this circuit. Okay, to understand this you have to assume a circuit. Okay, now it is told that a switch is given and the switch is in position A. The switch is in position A for a long time. Okay, the switch is in position A for a long time. Okay, now at t is equals to 0, the switch is thrown to position B. At t is equals to 0, the switch is thrown to position B. So we have to know what do you mean by t is equals to 0 minus, t is equals to 0 plus, and t greater than 0. T is equals to 0 minus means I have said that at t is equals to 0, the switch is thrown to position B. That means before that the switch is not applied, the clock is not applied, and also the switch is in position A. So before that time, if we want to express before the time then we have to express it at t is equals to 0 minus, because the switch is thrown to position B when the clock is applied and when the clock is at t is equals to 0. So before that time, the time is t is equals to 0 minus when the switch is in position A. So t is equals to 0 minus means the position A. Okay, the switch is in position A. Now what is the meaning of t is equals to 0 plus? T is equals to 0 plus means the moment when the switch is just thrown to position B. Okay, the moment when it is just thrown to position B, that is t is equals to 0 plus, and t greater than 0 after some time the switch is thrown to position B. After some time of switch is thrown to position B, so that time is referred by t greater than 0. Now according to these three conditions, we have to replace capacitor, inductor and resistor in the following circuit or in the corresponding circuit. Okay, let's see. At t is equals to 0 minus or in steady state, since it is given that the switch is in position A for a long time. So at t 0 minus, position A means we have previously discussed that at t 0 minus means the switch is in position A. Okay, so it is in steady state. So at t is equals to 0 minus or steady state, any capacitor will be open circuit and any inductor will be short circuit. Okay, now at t is equals to 0 plus, the moment when switch is from A to B, the moment when it is switched to position A to B, if there is a charge stored in a capacitor previously, capacitor will be replaced by a simple voltage source. That will be very easy. If there is a charge stored in it in a capacitor, that will be replaced, the capacitor will be replaced by a voltage source only. If there is no charge stored in the capacitor, capacitor will be short circuited simply. Okay, now if the inductor has charge stored in it, then inductor will be current source. Okay, then inductor will be replaced by a current source. If there is no charge in the conductor, then inductor will behave like a open circuit. Now the third condition, at t greater than 0, capacitor will be replaced by a voltage source equivalent to V0 minus. What is that V0 minus? V0 minus is the voltage gained in steady state and 1 by S impedance in series. Okay, and at t greater than 0, inductor will be replaced by a current source, that is I0 minus by S in S domain, and an impedance of Ls parallel to it. Or it can be simplified in this way: inductor, a voltage source Li0 and an impedance Ls series with it. So all these three conditions are applied in it, and all these three conditions you have to, according to this all these three conditions, you have to replace all the volt capacitor and inductor. Okay, Now what are the steps? What are the steps to solve any transient problem? I think if you follow to this step, you will solve it very easily. Step 1, looking for the initial conditions. Looking for the initial condition. In question you have to look that if initial conditions are given or not. Okay, now step 2, if there is a change of switch position from one position to another, okay, then at first you have to calculate the final values of voltage across a capacitor and the current through the inductor while switch is in previous position. So if there is in transition of switch from one position to another position, then you have to calculate the final value of voltage across the capacitor and final value of inductor current through the inductor when it is in previous position. Step 3, then you have to replace the capacitor or inductor according to the condition at t0 minus or t0 plus or t greater than 0. According to this condition you have to replace capacitor or inductor. Okay, the replacement is different in different conditions. And last step is use KVL and KCL to find out the current or voltage across the capacitor or inductor or anything else. Okay, now for better understanding we have to move a problem. Okay, we have to move a problem. Now this is a problem of UPSC IAS 2010. Okay, this is a problem of UPSC IAS 2010. So question is, for the circuit shown in figure, the switch has been closed at position A for a long time. This is position A for a long time. At t is equals to 0, the switch is moved to B. Then find VCT for t greater than 0. Now follow these steps. Looking for the initial condition. Here the initial condition is not given, means the circuit is initially relaxed. Okay. Now step 2, if there is a change of switch position from one position to another, let's see if there is a change of switch position to another, one position to another. Here it is a change of switch position from position A to position B. So we have to calculate the final values of voltage across the capacitor. Okay, now final values across the voltage means steady state voltage across the capacitor. So we have to first steady state voltage, we have to calculate the steady state voltage across the capacitor. So in steady state capacitor is open circuited. Now due to this open circuit, open circuiting capacitor, we have to first determine V0 minus. So let's see. Okay, so that is 3K and that is 5K. So what is that VC0 minus? VC0 minus will be 25 volt, because this is in parallel. So whatever the voltage drop across this 5K ohm resistance, that will be the VC0 minus. So VC0 minus will be 25 volt. Okay, now move to next sentence in that question. At t is equals to 0, now the clock is applied. At t is equals to 0, the switch is moved to B, means there is a transition from A to B at t is equals to 0, and we have to find that VCT, the voltage across the capacitor, at t greater than 0. So at t greater than 0, we have to replace capacitor. Now look at this condition. At t greater than 0, capacitor will be replaced by a voltage source, whatever the voltage gained in it in steady state, and 1 by SC impedance in series if previously charged. Okay, so we have to replace capacitor with a voltage source and 1 by SC impedance in series we need. So let's see. Okay, so this will be the circuit at t greater than 0. At t greater than 0, this will be the circuit. Okay, now we have to find the VCT. So in S domain that will be VCS. So VCS will be this voltage. So this voltage will be VCS. So if we have found that IC, that the current flowing through this circuit, then we can easily find VCS, because VCS is neither that IS into 1 by CS plus 25 by S. Okay, from using KVL we can easily see that VCS is equals to this thing. So we have to first find IS. How can we find IS? IS can be found by using KVL. Okay, so IS will be 30 minus S minus 25 by S divided by 4K plus 1 by SC. Okay, now 5 by S divided by 4K plus 1 by SC. Okay, so we have to put those values of C. We have to put those values of C, and then you have to solve it. Then you have to solve it, and then you have to find IT, inverse Laplace transform. Then you have to do an inverse Laplace transform of IS, and you can find IT. Okay, now if finding IT, so okay, leave that IS. Okay, IS, you have to find IS. Now put that IS in this expression, and then find VCS, and then inverse Laplace of it. So VCT will be easily found at t greater than 0. Okay, now move to next question. It is given that the capacitor is initially charged. That is, capacitor is initially charged to V0 is equals to 2 volt, and a switch is given that is closed at t is equals to 0, and 0.25 Henry that is not initially charged, and the resistance is there, that is 0.25 ohm. We have to find the voltage, this V voltage at t is equals to 0 plus. So t is equals to 0 plus, we have to replace all the capacitor and inductor according to the condition t is equals to 0 plus. Let's see, at t is equals to 0 plus, the moment when switch is equals to close, if there is voltage across the capacitor previously, okay, capacitor will be replaced by simple voltage source. In here, capacitor has a voltage previously, so it will be simply replaced by a voltage source of 2 by S. In S domain, that will be 2 by S. Okay, then a switch is there, switch is closed at t is equals to 0. Now what will be the inductance? If, let's see, if there is no charge in inductor will be open circuited. Okay, clearly seen there. So inductor will be open circuit here. Okay, and resistance act as same, so that will be 0.25. so here it is 2 by S, and here it is 0.25 ohm. So now this will be VS. So VS will be obviously 2 by S. VS will be obviously 2 by S, because these two are in because the current is flow and the voltage drop is there, that will be obviously 2 by S. Now so VT will be obviously equals to 2 volt. Okay, so easily in this way we can found VT. Okay, so if you like this video, then subscribe my channel. I will show you the better technique of some lessons.